Treasure doesn't glitter. It doesn't shine. It hides in the most unexpected place. Within a rock you've seen 100 times before, and today you're going to learn how to see it. Not just with your eyes, but with the mind of a prospector. Because this isn't a legend. This is geological truth, backed by science and discovered by accident. Let's begin. In 1988, in a rural part of Queensland, Australia, a farmer stumbled across a dark, iron-like rock while clearing his land. It looked like nothing special. Heavy, yes. Rough around the edges. Covered in dirt. But it didn't break like the other rocks. It rang when struck. Out of curiosity, he tossed it into a barn. For 10 years it lay there, forgotten. Until one day a geologist visiting the property spotted the rock and asked to examine it. What he discovered would rewrite what we thought we knew about Earth's hidden messages. The rock was a massive ironstone nodule, the kind that forms in areas rich in gold. This farmer had been sitting on a geochemical billboard, a natural clue, formed over millennia, pointing straight to a gold deposit just beneath the soil. Across the world, from Alaska to Zimbabwe, scientists have been quietly mapping the relationship between surface stones and buried riches. These indicator rocks don't contain gold themselves, but they form because gold is nearby. Why? Because of fluid movement beneath the Earth's crust. Hydrothermal systems. When hot fluids filled with dissolved minerals rise from deep faults, they interact with surface rocks, forming ironstones, quartz, jasperoids, and even green schists. The most innocent-looking rock could be the surface expression of a treasure vein meters below. This isn't speculation, it's geochemistry in action. And once you learn the signs, you'll never see your local landscape the same way again. Let's get practical. What are the rocks that often mean something valuable is close? 1. Ironstone nodules. Heavy, dark, and rough, sometimes magnetic. They form in areas with significant mineralization. Where there's ironstone, there's often a chemical reaction from gold-bearing fluids. 2. Jasper and jasperoid. These bright red or orange rocks are altered versions of limestone, cooked by nearby hydrothermal activity. They're textbook signs of potential gold mineralization zones. 3. Quartz veins. The classic prospector's clue. White or smoky quartz veins that cut through bedrock can be pathways for gold-bearing fluids. Look for veins with iron staining or tiny flecks of sulfides. 4. Black schist. Dark metamorphic rock rich in graphite and other minerals. In some regions, especially in Africa and Canada, this rock is associated with ancient gold belts. 5. Gossan. This rusty, sponge-like rock is the oxidized shell of sulfide ore bodies. It may look like burnt sponge cake, but Gossan can be a neon sign for treasure. Here's the suspenseful twist. These rocks are often ignored. Why? Because they don't look like treasure. They're not shiny, they're not beautiful. They look like trash. But gold isn't about looks, it's about formation. And formation is invisible, unless you know what to look for. One of the biggest mistakes people make is assuming that all gold is found as nuggets. In reality, more than 80% of the world's gold is microscopic, locked in quartz, in sulfides, or even within arsenopyrite. And these host rocks, they're the keys. Here's something even more surprising. Plants can tell you where treasure lies. Certain indicator plants, like sagebrush or eucalyptus, pull trace amounts of gold up through their roots and into their leaves. In Australia, gold has literally been found in tree bark. The presence of certain rocks and plants together, that's no coincidence. It's nature's layered clue system. Back in the 1920s California, prospectors used nothing but a hand lens and a rock hammer. They didn't have maps, they didn't have GPS, but they did have one thing: experience with rocks. One man named Tom Blevins found over 300 ounces of gold by tracking quartz stringers laced with black iron staining deep in the Sierra Nevada. In Alaska, entire gold rush towns formed around iron-rich gravel deposits, found only because one hunter noticed that every creek with a certain red-stained rock seemed to yield color in his pan. These are not myths. These are field-tested methods, still in use today, and you can use them too. But it doesn't end with quartz or shale. Let me take you deeper. there's a quiet stone that sits unnoticed by most people. Serpentine. To the untrained eye, it looks dull, greenish, and even unattractive. But to geologists and treasure hunters, serpentine is a whisper from the earth. Why? Because it forms in regions where hydrothermal fluids once surged, and those same fluids often carry gold, platinum, and even diamond-bearing rocks into crevices and fractures. In regions like California and parts of Europe, the presence of serpentine rock led to the discovery of nearby mother lodes of gold, often trapped in the quartz veins lacing through it. It's the kind of rock that tells a story of pressure, of transformation, and of possibility. But let's step away from gold for a moment, because some common rocks aren't just signs of treasure, they are the treasure. Take garnet schist, for example. It's often used as a decorative rock in landscaping or crushed for industrial use. But in its natural untouched form, garnet schist often contains visible, gem-quality garnets nestled within. Red, fiery, durable. These garnets are found in metamorphic zones, areas of intense heat and pressure, the same zones that might also reveal emeralds, sapphires, or even rubies. And here's where it gets fascinating. Garnets are indicator minerals. In some terrains, their presence hints that diamond-bearing kimberlite pipes might not be far off. Yes, a rock you might kick on a trail could be pointing to millions of dollars worth of treasure under your very feet. That's the beauty of geology. You're never just looking at a rock. You're looking at a time capsule, a map, a secret code. Then there's basalt, a stone so common that entire mountain ranges are made of it. Dark, dense, heavy. It's easy to overlook. But in regions where basalt cooled rapidly from volcanic activity, pockets of zeolites and even peridot crystals have been discovered, tucked into vesicles, those tiny bubble-like cavities. Now imagine cracking open a rock that looks completely mundane, only to find a green glimmer from inside. It's like opening an old book and finding gold leaf between the pages. And what about ironstone concretions? These round, sometimes alien-looking formations often contain pockets of opal, especially in Australian and American desert zones. These stones almost never break easily, but those who've dared to slice or smash them open, sometimes with no clue of what they held, have been rewarded with glowing play of color flashes, as if the stone was hiding a galaxy inside. It's nature's poker face. One of the most underestimated geological clues comes in the form of calcrete. Found mostly in arid zones, it forms crusts or layers above the ground, often hiding what lies beneath. But mineral explorers know this truth. Where there's calcrete, there could be nickel, uranium, or even gold anomalies beneath it. In parts of Africa and Australia, companies began analyzing calcrete crusts chemically, and that data led to massive discoveries of mineral deposits that had been hidden for millennia. These were places people lived near their whole lives, without realizing that beneath their feet were riches that could change their world. So how do you know if that common rock you just stepped on is just dirt or a doorway to something greater? Here's the truth. You train your eyes. You slow down. You observe. You learn to read the terrain. A cluster of red-stained rocks might be iron oxide, and a signal of a hydrothermal vein nearby. A sudden change in rock texture or color along a trail, that's a contact zone where different rock types meet. A favorite hiding place for veins of gold, silver, and gemstones. A dry riverbed with unusually dark, heavy stones could be black sand, a dense mixture that often sits close to placer gold. These aren't guesses. These are geological signatures, the fingerprints of Earth's hidden processes. Want the real edge? Learn to recognize the difference between host rocks and indicator rocks. A host rock holds the treasure, but the indicator tells you that you're getting close. Take chromite, a dense, black, metallic rock. On its own, it's valuable, but in certain zones, it's also an indicator for platinum and diamond pipes. Or epidote, a green mineral found in metamorphic zones. It's often found near gem pockets and quartz seams. Once you know what to look for, every hike becomes a treasure hunt. Every gravel road becomes a potential gold trail, and every boring rock becomes a mystery waiting to be cracked open. So the next time you're out walking in nature, remember this. Shock waves, high-pressure graphite structures, and even radiation damage all point to a cosmic birth. According to leading geochemists, carbonado likely formed over 2.5 to 3.8 billion years ago when an asteroid collided with Earth. Or maybe it was space dust condensing into diamond form before Earth was even a planet. And here's the most shocking twist. These diamonds are only found in two places, Brazil and the Central African Republic. Both were once part of the same supercontinent, Gondwana. Coincidence? Maybe not. Black diamonds are tough, and I mean really tough. Carbonado is made up of millions of diamond microcrystals fused together like a cosmic sponge, making it the hardest form of diamond ever discovered. While ordinary diamonds can chip and crack, carbonado absorbs shock. That's why some industrial drills and cutting equipment actually use crushed black diamonds. Their porous structure and irregular surface make them incredibly difficult to cut and polish. But once done right, their luster is hypnotic. It's not the sparkle of a white diamond. It's more like staring into a galaxy of shadows, dark, endless, powerful. And if that wasn't unique enough, they're also electrically conductive, something nearly unheard of in other diamonds. Scientists believe this property could be linked to their exposure to cosmic radiation during formation. Okay, let's talk numbers. How much is a black diamond worth today? Well, carbonado used to be considered worthless. Jewelers didn't know what to do with them. Their unpolished appearance made them undesirable in traditional markets. But in the last decade, things have changed drastically. With the rise of alternative gemstone trends and celebrity endorsement, the black diamond has become the rebel of the luxury market.